Hey, it's Dr. Tracy, and we are continuing with Chapter 2, Data Storage Formats. In Section 2.3, after you've completed the exercises from the first part, there is a mathematical equivalence of binary and decimal. So the way that we figure out the mathematical equivalence of binary and decimal is kind of based on that positional notation that I was talking about in the first video. And that is, with decimal, we have the ones place, the tens place, the hundreds place, the thousandth place, and that is its positional notation. When we are dealing with binary, we have the ones place, the twos place, the fours place, the eights place, the 16ths place, the 32s place, the 64s place, because that's the way that you count when you're using binary. So when we do this positional notation, we write that according to its value. The number 123 in decimal means we have 1 in the hundredths place, 2 in the tenths place, and 3 in the ones place. By doing the math and calculating that value is how we figure out what it is, which would be the same as the way that is written in figure 2.3.2, which says 1 times 10 to the second. Of course, that's 100. 2 times 10 to the first, and 3 times 2 to the 0, showing its positional notation and its base. Now, that is an important point. Its positional notation and its base. We're using base 10, so we do 10 to the second, 10 to the first, and 10 to the 0, which 10 to the 0, any number to the 0 is 1. Now that we know its base and its positional notation, we know its value to multiply the value that is in the inside. Knowing the base or the radix of a number is a good way to represent it. The figure in 2.3.3 is the way that we can calculate what the value is of any number based on its base and its positional notation. So in this right here, the algorithm 2.3.1 is binary to decimal. And that means that we go through each value and we multiply the value in the position times the base to its positional value, where the first one will be 0 and the second one will be 1, indicating that we have gone through all of the possible digits within that system at least one time. So that's going to create the way that we can convert decimal to binary. And also, if you look at these exercises that are at the end of this chapter, we look at these values and convert an 8-digit binary number to decimal by doing it the opposite way. In an 8-digit binary number, 10100101 is showing that there is 1 in the ones place. There's a 1 in the fours place. And by converting its number based on that algorithm, you can find the answer. Here's just a note about these problems. Sure, you can find the answer right here. But what I'd like for you to do is try and figure it out and know that you have the answer to show it for you. I want you to not just copy and paste the answers that are listed here. I'd like you to show these in your own words. Demonstrate your understanding. It's important. Now, this is the next one in 3 says convert these following 8-bit binary numbers by hand. And then here's 16-bit binary to decimal, and develop an algorithm to convert hexadecimal to decimal, and then convert those using this algorithm. An algorithm is a problem solution. So develop a way, what did the calculations be, regardless of what the number is, and see if it works. Section 2.5, after you finish the exercises, talks about unsigned decimal to binary conversion. Signed numbers mean that they have positive or negative associated with them. But signed, positive numbers is not unsigned. It just means that we don't have a negative equivalent. But when we are dealing with unsigned numbers, we have a greater value that can be stored within memory, because -1 is stored as a separate number from 1. But if we don't have negatives, now we can double the amount. So this section is talking about what unsigned numbers are, and then how we can find the difference in them. When you see that quotient, that's referred to as the modulus operator. It means that if we divide that any number by its quotient, we should get the remainder. And the remainder is because we use integers and not decimal places. So there's some exercises here that will let you kind of look into doing that. And the final section of this chapter is memory. I'll separate that one out.